ERPs can also allow us to look at what the brain does in response to oddities in language. And there are lots of different kinds of oddities, and so we'll look at a couple different kinds here. One kind of oddity is to use an unexpected word that doesn't make sense in the sentence. In one study, participants would listen to sentences that either did make sense or didn't make sense, like whipped cream tastes sweet, that makes sense, or whipped cream tastes anxious, that doesn't make sense. And when they would hear a sentence that didn't make sense, then they had a response in the N400. Now, this is a little confusing, a little counterintuitive, because the positive and negative axes here for ERPs are basically backwards from what you'd normally expect. This is just a conventional issue. There's no particular reason why. It just seems like some weirdo did that at the beginning of ERP research and it's just stuck. So here we see that these are the millivolts on the positive side, even though they're lower, and these are the negative millivolts, even though they're on the what you'd think would be the higher side. So this is reversed. And when you see this peak right here, we call it a negative peak because this is the negative side on the y-axis. So there's a difference here at the N400, or in other words, the negative peak around 400 milliseconds, a little before, a little after, but around N400 there's some distinction between those sentences that do make sense and those that don't. Notice that this point right here, this 0 point of milliseconds, is not the beginning of the sentence, but the beginning of the word onset when either the congruent or discordant word was presented. So this is the time point when the word was said, either sweet or anxious, and it took about 400 milliseconds before the participant was able to make some distinction in their brain, in their brain patterns of whether that word made sense or didn't make sense in context. We also see that there are grammatical errors, and these grammatical errors are processed in a different way than words that would or wouldn't make sense in a sentence. So in this study, participants either heard the spoiled child throws the toy on the floor, or the spoiled child throw the toy on the floor. And here the 0 point would be where the word throws or throw was originally said, and it would take about 600 plus or minus 600 milliseconds before we see some positive peak here, some difference in the processing of those sentences that do make syntactic sense and those that don't. Now this was exciting for some time because it seemed to suggest to researchers that there was a different pathway processing information about meaning and information about syntax in the brain. However, in the years since then, we've learned that the N400 isn't exclusively dedicated to processing words that do or don't make sense in a sentence, but rather they could identify words that do or don't make sense in a list. It could identify, like, if you saw an action that was using an object in a strange way, such as shaving with a broom, or if you saw a familiar versus an unfamiliar face, or if you were to see an incorrect answer to a mathematical operation, then all those things would spark would spark some N400 effect, where what you were expecting to observe was not what you actually did observe. Likewise, the P600 effect can be observed in situations of musical abnormalities, where given a sequence of music, we might hear one note that stands out as being out of tune with the others, and when that happens, about 600 milliseconds after the onset of that note, we would show some peak difference compared to those musical sequences that didn't have a note out of tune. These pieces of evidence seem to suggest to us that while EEG can be used helpfully to understand the timing of different processes in the brain, these processes are probably not unique to language processing, that rather we probably have co-opted the use of general cognitive structures in allowing us to speak and use language. It's also noteworthy that some research has been done on minimally conscious patients, which is a state that's like being in a coma, but you're a little bit more aware than in a coma. In other words, your brain waves still go through normal sleep and waking cycles, but while you're in a waking state, you don't seem to be aware of your environment or ever interact with the individuals around you. The individuals who are in a minimally conscious state seem to still exhibit these N400 waves, and sometimes even these P600 waves, suggesting that they are processing linguistic material and can anticipate what words might be concluding a sentence, and when a word doesn't match their expectations, then their brains will wig out and recognize that that's not what they were expecting. Shockingly, individuals in one study were able to show different brain activity according to the instructions that were given to them by the experimenter. The experimenter would ask them to either just listen to a list of names and during the course of that list state the patient's name, or would be asked to count the number of times that they heard their own name in the list. And both of the lists in this study were exactly the same, but the individuals would process the information differently depending on whether the researcher had given them instructions to just listen to the list of names or to count the number of times that their name had been said in the list of names, suggesting that they're able to respond to instructions, and even in a minimally conscious state, they seem to have some cognitive control, some ability to be consciously responding to their environment.